computer. Hi, sorry if you're watching this on YouTube, I forgot to press record, but you didn't miss much. Okay, I was just rambling, saying hope you had a good weekend earlier. Anyway, the different kind of endocrine glands, right? A lot of these glands we have seen already throughout the course, right? The pancreas we saw in the digestive system, where we were focusing on its exocrine properties, right? So exocrine is different from endocrine in the sense that the exocrine gland secretes through some kind of duct, right? And in the case of digestive system, the pancreas secretes digestive enzymes and sodium bicarbonate through the pancreatic duct into the duodenum. So that makes it an exocrine gland, right? Whereas an endocrine gland, they secrete directly into the bloodstream. Okay, there's no duct involved, right? So often the hormone that is being secreted will travel throughout the body through the bloodstream, and then it will affect its target, sometimes single target, sometimes multiple targets, and these are the major glands. We'll label it later on the study guide. But like I said, right, most of these we have seen, here and there throughout the lecture. So we will begin from head all the way down to the bottom later on. But let's start with the hypothalamus and the pituitary gland. We learned quite a bit about the hypothalamus and pituitary already, especially last week, right? We saw how there is a relationship between the hypothalamus and the anterior pituitary gland. And in some cases, in the kidney, right, we saw how the hypothalamus have a relationship with the posterior pituitary gland, right? So that, in general, the hypothalamus is called a master gland, okay, because it secretes hormone that has an influence on how other glands function. And not only does it regulate a lot of processes related to homeostasis, but it also controls things like, heartbeat, body temperature, water balance, as we saw this earlier, right? And the circadian rhythm, right? That the sleep-wake cycle, right? That has the hypothalamus also plays a role in that. And if you remember, the hypothalamus is also part of the limbic system, right? So it's a tiny structure in the brain, but it's involved in many complicated processes. Okay, so the hypothalamus is connected to the pituitary gland through a tiny stalk-like structure, which is called the infundibulum. Okay, and that is where the axons are going to be extending from the hypothalamus to the posterior pituitary gland. I'm going to draw a picture of this in your study guide in a bit. I just want to read through the words with you first. So here it is. I just show you the relevant structure, and here is the hypothalamus. That's the infundibulum. And because the person is looking to the left on the computer right now, so the left side, it's going to be the anterior pituitary gland. Okay, and then of course the right side is the posterior. But if the head were to turn the other way, then it would be anterior on the right, right? So typically in diagram, the bigger one is the anterior one, right? So this whole gland, because it's part of the brain, it's going to be surrounded by, of course, your meninges, right? Dermata and all those stuff that we learned, right? And then you're going to have the cella turcica. I think that's how you pronounce it. I think it's turcica. Some people say turcica. I think both are okay. And that is, of course, like the groove that is created by the sphenoid bone, right? So there is the sphenoid bone right here. Oops, hold on, my pen's not working. Just try to replug it. There we go. Okay, that's the sphenoid bone. Okay. And the groove here at the top that protects your pituitary gland, right? So that's that. All right. This shows the relationship between the pituitary gland And sorry, let me just go back for a second. I forgot to mention the optic chiasma, right? That's where your optic nerve from both eyes are going to cross the middle, right? And it's just going to cross right in front of the hypothalamus. So this shows the relationship between two groups of neurons in the hypothalamus. Right? We have the green group, which extends their neuron all the way to the posterior pituitary. So note this diagram is opposite compared to the previous slide, right? Probably the person is looking the other way now. And for the anterior pituitary gland, there are no neurons that are extended directly into the gland, okay? They just kind of stop in the infundibulum, and they would secrete some controlling hormone to regulate the secretion from the anterior pituitary gland, right? Okay. So let's write all these things out in the diagram in the course pack, and hopefully it will make sense. This is number 2 on your study guide. Okay, so just label the key parts here first, right? Of course, you should know that this is the hypothalamus. That this whole thing here, right? Hypothalamus. And you can also tell which one is the anterior and posterior by looking for the optic chiasma. Right? Optic chiasma is always at the front on the anterior end. Okay, so over here, that is the anterior pituitary. I'm just going to put AP. And this is the PP, posterior pituitary. Now, we did this last time already, but let's go through it again. We have some neurons in the hypothalamus that extend their axon, right, into the posterior pituitary. Okay, so it goes through the infundibulum, goes right down here. Okay, so there are hormones that are made in the hypothalamus, but then they're stored and released from the posterior pituitary gland. And we learned 2 of such hormones, right? Okay, so ADH. You know what? Maybe I shouldn't use green because I'm going to use green later on for something else. Give me a second. Let me see if I can change this. I don't know. Let's go with blue here. There we go. Okay, so there are 2 hormones that we learned that are made in the hypothalamus, but then stored and released from the posterior pituitary. Can you guys help me out? Which 2 hormone was it?
LNH.
Close. That ANH is the one from the heart. Is the other one that you're thinking about, maybe. Maybe a second try if you want. Okay, zeaxanthin oxytocin, yeah. What's the other one? It also begins with an A, yes. Yes, that's right. Yeah, that's a ADH, right? ANH is the one from the heart. ADH is the one from the hypothalamus. ANH is the one from the heart. Okay, so this one, ADH, antidiuretic hormone, right? And oxytocin, they are both produced here, packaged into little vesicles that will be transported down to the posterior pituitary until they are going to be released. Now, just very briefly, ADH helps you conserve water, and the oxytocin produce uterine contraction, right? As well as the letdown of the milk. Okay, so more on that later in the PowerPoint. Okay, we have another group of neuron here, and they would have the neurons extended and then they just stop short at the infundibulum. And what happens is, last time I told you, right? They will be secreting two kinds of hormone, regulating hormone. Right? So it'll be secreting releasing hormone, as well as inhibiting hormone, right? This is too thick. And these hormones will then control the anterior pituitary gland, right? To allow certain hormones to be released, to suppress the release of certain hormone, depending on what the needs of the body are. And we will not be learning any inhibiting hormone. We'll be learning some three releasing hormone. But I just want you to know the difference between them, right? Okay, so this gives the permission for AP to release a hormone, and this would suppress the anterior pituitary gland so it does not release certain hormones. Now, the anterior pituitary gland has 6 hormones that we're going to look at. Okay, you already know 2 from last week. What are they? Come on, you guys can do it. What are the 2 hormones that are secreted from the anterior pituitary gland? We'll learn it on Wednesday last week. Yep, Shelly, that's right. There's LH, right? So from
And FSH.
and FSH, that's right. So these are both hormones that are related to the reproductive system, right? In both male and female. Okay. So I'm gonna add a few more. It's okay if you don't know what they are just yet. We're gonna learn it, but I want to list it here so we have a complete diagram, right? So we have TSH, which is thyroid stimulating hormone. Okay, and as the name implies, the thyroid stimulating hormone will stimulate the thyroid. We also have something called ACTH. This one is, the name is more complicated, but AC stands for adrenocortical, which means it's going to stimulate the adrenal cortex. Okay, so these hormones, right, I am gonna put a cloud bubble around it. Okay, and I'm gonna put a star. Okay, so these hormones, we call them tropic hormone. Okay, why? Because they target another endocrine gland. So LH, FSH targets the ovaries in females and testes in male. That's an endocrine gland. TSH targets the thyroid gland. That's another hormone gland, endocrine gland. ACTH targets the adrenal cortex. Right? So because they target another endocrine gland, we call them tropic hormones. And then we have non-tropic hormones. They don't have a specific endocrine target. They just kind of target like all over the body. We have GH, which is growth hormone. Again, don't worry about what they stand for at this moment. We're gonna talk about it throughout the lecture. Okay, there's growth hormone, and then there is the PRL, prolactin, which makes milk for nursing mothers. Okay, so these are non-tropic. Now, in order to release these hormones, the anterior pituitary gland will require like a signal, right? A permission from the hypothalamus. So there are different kinds of releasing hormone. And you will know it's a releasing hormone because they all end in RH. Right? So we learned there's GnRH, right? Gonadotropin releasing hormone. So if you have a highlighter, Right? We can highlight GnRH. That's the permission for LH and FSH. Okay. Now there is another signal for a different kind of hormone. We have TRH, thyroid releasing hormone. Right? If it ends in RH, you know it's from the hypothalamus. And the thyroid releasing hormone will be the permission for the anterior pituitary gland to release thyroid stimulating hormone. Okay. And I hope you see the trend here. If I need to release ACTH from the AP, I would need another permission from the hypothalamus, and that would be like CRH. Okay. That one is cortical releasing hormone. Okay, so each belongs to a particular pathway. Okay, now don't forget there are also inhibiting hormone to stop the release of these things, but it's too much. Okay, we're not gonna talk about it. Does anyone have any question about this diagram here? You know, other than what they stand for, right? We're not going to worry about that right now. The key idea is to know the relationship between hypothalamus and each of the pituitary gland. Any question? Okay, let's go back to here. So this basically conveys the same information. It's too small for you to read right now, but you can read it on your own. When you
On the other slide that you drew, what did you say about tropic hormones?
Oh, the tropic hormones are the hormones that are going to be targeting another endocrine gland. So for example, LH and FSH, they target the gonads, right? The testicles and the ovaries. Those themselves are endocrine glands. TSH targets the thyroid. ACTH targets the adrenal cortex. So each of these targets are endocrine glands themselves. And so by definition, they're called tropic hormones. Okay.
Thank you.
Yeah. All right. So two hormones are produced by the hypothalamus and then are transported to the posterior pituitary gland, and then they will be released from the posterior pituitary gland when the right signal arrives. So let's take a look at oxytocin. Oxytocin is not much function in men. I'm not sure if men actually produce it. If we do, then it's a very low level, I think. But for female, it's particularly important because it causes uterine contraction, right, during childbirth, as well as nursing, right? So to let the milk come out. And last week, I kind of explained that this is an example of a positive feedback where the trigger, the stimulus for the release of oxytocin will result in an exaggeration of the trigger itself. Okay, so for example, during labor, the more contraction you get will trigger the posterior pituitary gland to release more oxytocin, which then goes back to the uterus and create even more contractions. Similarly, for nursing the baby, the more the baby suckles, right, on the breast, the more oxytocin is going to be released, which then cause more milk to be released, right? So this creates like a feedback cycle that would ultimately keep on exaggerating the contraction until the baby comes out. Okay. Similarly, like when feeding the baby, right? Like you don't want the milk to stop, right, until the baby stops like until you finish feeding the baby, I guess, right? And so it also creates a positive feedback loop. Now it's interesting because you know, it's not just the physical sucking action of the baby that would trigger the letdown of the milk. There are other pathways. Sometimes, like if you hear your own baby cry, right, then your body associate that with like it's time to feed the baby, and then that could also trigger a little bit of a release of the oxytocin, and then the milk might also come out. So there are other, you know, sensory trigger for the release of the oxytocin. Okay, not just like physically suckling from the baby. And then the other one, of course, is ADH, which we talked about before already. It acts on the distal tubule and the collecting duct. That would help the boy, help the body. Sorry, help the body to conserve water. Okay, and that, of course, is triggered by high blood osmolarity, right? Like not enough water in the blood. All right. We already talked about this, right? Relationship between the hypothalamus and the anterior pituitary gland, right? So we have two groups of hormone, ones that turns on, allows the anterior pituitary to release, and then one that inhibits it. Okay? And just for, you know, the sake of repetition, we learned 3 kinds of releasing hormone. You know it's a releasing hormone because it ends in releasing hormone, RH, GnRH, TRH, CRH. Okay. You know, as complicated as this seems, people usually do pretty well in an online setting for this hormone unit. There are advantages, right? Because you could have a like the hormone chart that you could quickly reference to, right? So like you obviously it's good that you memorize all these hormones, but then you know in reality, right? When you have a reference chart, it's much easier. So you know don't feel overwhelmed. You will be okay. All right, now we have some non-tropic hormones, right? These are hormones that are not going to be affecting another endocrine gland. So there is prolactin that we talk about, PRL, and the body starts making more and more prolactin at the beginning of about like 5th month of pregnancy. And you know, you keep on making it after childbirth until you stop nursing the baby, right? So in some places where you know women don't get like a maternity leave necessarily from work, or they don't get as long of period as we do in Canada, right? They may not be able to nurse the baby, right? So they have to do formula, for example, and then you know there are medication that the doctor can prescribe to basically block the PRL so that you don't produce the milk, right? Because you won't be feeding your baby, like breastfeeding your baby. But when you do have the PRL, it causes the mammillary glands in the breast to produce the milk. Okay, it changes how carbohydrate and fat is being metabolized because you got to redistribute the nutrients and you know put some of it at the milk. And you know if you're a mother, you probably would know the like if you nurse your baby, right? You probably notice that uh, the how do you say it? Like the contents of the milk actually changes, right? As your baby grows. Okay, like it's more like more fat content in it towards later on compared to the beginning, right? When the baby is just like you know just fresh out of the womb, right? So like the nutrient needs is different as the baby grows, right? And so your body adapts to that, right? And change how metabolism is working in the body, and it changes the contents of the milk basically. Thasana, you wanted to say something? I saw you unmute.
Oh, that's an accident. Sorry.
Oh, no, no worries. So obviously low levels of prolactins in male as well as non-pregnant people and non-lactating people as well. Okay, so once you stop feeding the baby, right, the stimulation is not there, and then your body will slowly wean off the level of prolactin. Okay. All right, the other non-tropic hormone is the is the growth hormone, right? So as the name implies, growth hormone helps you grow. Right? It targets mostly muscles and bones for growth, right? Particularly important during the developmental ages of our lives. Once you reach, your maximum potential height, like having more growth hormone is not really gonna do much, right? So not enough growth hormone during childhood, it's going to lead to pituitary dwarfism. There are other causes of dwarfism, but this one has to do with the anterior pituitary gland not making enough growth hormone. It's genetic. And if there's too much growth hormone, then a person has pituitary gigantism. Okay, so I don't know if this picture is still like the record, but when I looked it up like a couple years ago, this is the was the tallest man, I guess. I don't know if he still is, and he's from Turkey, and he is 8'9". Okay, that's pretty tall, right? And then next to him is the shortest person, okay, from Nepal. Right? So they got together and took a picture just to show the contrast. So he would have pituitary gigantism, and she would have pituitary dwarfism in this particular case. Okay, and typically pituitary gigantism also is linked to shortened lifespan, because like your heart is working much harder to compensate for the bigger statue, and that could put a certain strain and stress on the heart. Okay, so non-tropic hormone, we got the prolactin and the growth hormone. A lot of students confuse the prolactin from the oxytocin. Okay, oxytocin is made in the hypothalamus, stored in the PP. Okay, that's for letting the milk come out. Okay, the letdown of the milk. The prolactin is produced in the anterior pituitary gland, and that's for making the milk. Okay. Min asks, would pituitary dwarfism affects the person's mental growth? No, not that has nothing to do with it. Yeah, it's just the physical stature, right? There's no the mental development is not reliant on growth hormone, so I don't think there is a problem there. Okay, so next we have the 4 tropic hormones that we already labeled, and this just spells it out for you, right? Like what they stand for, right? We already learned FSH, the follicle stimulating hormone, which stimulates the follicle development in female and spermatogenesis in male. And then we have the luteinizing hormone, which either triggers the release of the egg, right, ovulation in female, or it triggers the production of testosterone in male. So that's something that we learned last time. And then we also have 2 additional ones. We have the thyroid stimulating hormone. We have the adrenocortical tropic hormone. Okay, so this one targets the thyroid gland, right? This one targets the adrenal cortex, right, which is the those glands that are on top of your kidneys, right? All right, let's see. Just try to do this from memory, see how much you remember. I think I repeat quite often already this morning. Hopefully, it has helped you remember it. Okay, thank you for participating. I'm not gonna dwell on this too long. But yeah, you guys, most like the people who chose something got it right. We have the oxytocin as well as the ADH. Very good. Moving on. Which of the following is a tropic hormone? Very good. Okay, so like we have LH, FSH, and TSH. Those three are tropic hormone. The other two, because they don't target another endocrine gland, right? Like the mammillary gland is not an endocrine gland. That's an exocrine gland, right? So the prolactin is non-tropic, and growth hormone targets bone and muscle, which also makes it non-tropic. Okay, next we're gonna do the thyroid gland and the parathyroid gland. Most of this some of it we have seen already. So let's see. Thyroid gland first. Thyroid gland produces something called triiodothyronine and thyroxine. We can just call them T3 and T4. Okay, so as you can tell from the name, it uses iodine, right, to make the hormone. And it's the only gland in the body that uses iodine. Right? So the T3 and the T4, they have overlapping functions. Generally speaking, they work together to increase your metabolic rate. Okay? It doesn't target a particular cell. It just causes all your cells to metabolize a little bit faster. Okay, so you break down more glucose, and then you get energy from that process, right? So more on how they work later on in terms of a feedback loop, but that's what T3 and T4 are for. Okay, they increases your metabolic rate. We learned calcitonin already, right? We need calcitonin if you have too much calcium in your blood and you want to put some of them into your bones. You want to tell the kidneys to reduce the calcium uptake, right? So that's from previous unit. And I'm going to explain to you soon, I guess, the relationship, the negative feedback relationship between the T3 and the T4 with the anterior pituitary gland as well as the hypothalamus. Okay, like it will make more sense when I write it out. I just want to go through the slides with you first. Now, on the back of your thyroid gland, we have the parathyroid gland, and that, of course, secretes the PTH, right, the parathyroid hormone. And PTH is antagonistic to calcitonin. You would need PTH when you don't have enough calcium in the blood. And the PTH will increase the absorption from the kidney, from the bones, as well as activating vitamin D so that you can increase absorption from the intestine as well, right? So there are three separate targets here. Again, that's all news. Okay, so let's do this HPA thing. Where is it? Okay, let's go to this this page right here. There's a huge chart here that we can do. So let's use the reproductive system as a template, okay? And then we will see how the other two pathways are similar to the reproductive system. Okay, since we learned that last week already, right? And I'm going to use the female one as a template because that one we spend more time explaining. Okay, so this is called the HPA, which stands for hypothalamic pituitary axis. Okay, so each one of them is axis, AXIS, and then you have multiple axes, right? It basically shows the relationship between how the hypothalamus interact with the anterior pituitary gland, and then how it interacts with like the third gland. There are three glands that are involved in these pathways. Okay, so it's like gland, and then some kind of effector, some kind of target at the end. Right. So let's start with the reproductive system. Okay, and again, I'm using the female one. So at the beginning, we are gonna have I'm simplifying it here. I'm not going to include all the details, but essentially what happens is we will have a drop in progesterone, for example. Okay, low progesterone. Okay, what does low progesterone do? Low progesterone triggers the hypothalamus to secrete Do you guys remember? What does low progesterone trigger the hypothalamus to secrete? Yeah, GnRH, right? GnRH. Okay. So low progesterone triggers the hypothalamus to secrete GnRH, and then GnRH triggers the anterior pituitary gland to secrete FSH and LH, right? So of course they're like the first half and the second half, okay? As in like the lutein phase and the follicular phase, right? So what do they target? FSH and LH targets ovaries, and then it's going to secrete, and again, I'm gonna separate this into two parts here. And we're gonna have let's trigger the release of estrogen and progesterone. Okay. And then what happens is it will result in so like thickening, right? Thickening of endometrium. Right? Make sense so far, hopefully? All right, well, 1 second, guys. I'll be back. Sorry, just my kids are home. They need they needed my help for a little bit. Just 1 second, okay? Sorry. Sorry about that, guys. Okay, so both of them leads to the thickening of the endometrium, right? Now, the estrogen has a different effect than the progesterone on the hypothalamus and on the anterior pituitary gland. So if you remember, the estrogen actually will go back to the hypothalamus, and it will also go back to the anterior pituitary gland, and it's going to have a positive feedback, right? It's going to have positive feedback. It's going to encourage the hypothalamus and AP to release more of these hormones. And then on the other hand, the progesterone is going to go back and it's going to inhibit, right? The release of GnRH, FSH, and LH through negative feedback, right? Because by the time you have progesterone in your system, by the time you have the corpus luteum, it means that you already have the egg in the fallopian tube, right? So like it doesn't make sense to develop another follicle at the moment. That's why you want to suppress the GnRH and the FSH and the LH. So that's what we learned last time, okay? Now we're going to take a look at how this is similar in the case of metabolism. All right, in the case of metabolism. So in the beginning over here, when do you need to crank up your metabolism? Yeah, well, you need to crank up your metabolism when your metabolic rate is low, right? So over here, this is going to be decrease in T3 and T4. So when you don't have enough T3 and T4, it means you have low metabolism. Okay, metabolism. So the low metabolism, low T4, T3, T4 triggers the hypothalamus to secrete something. Okay, right. Can you guess what hormone this is? Look at the reproductive system. Right? We need a GnRH to trigger the release of FSH and LH. So what do I need here to trigger the anterior pituitary to release something? Let's go back to our diagram here and see if it's going to clue you in. Right? Which one do we need? Yeah, the TRH, right? The thyroid releasing hormone. That's exactly what we need. All right, so trigger the hypothalamus to secrete TRH, right? TRH then triggers the anterior pituitary gland to secrete TSH, thyroid stimulating hormone, right? And then thyroid stimulating hormone targets, as the name implies, the thyroid. Okay. And then the thyroid secretes what? T3 and T4. That's what we need, right? T3, T4, and then results in increase in metabolism. Okay. So you see, it's basically the same pathway, but it's just different hormones, right? That we're talking about. And of course, you don't want your metabolism to spiral out of control, right? You don't want it to keep on increasing and increasing and increasing. And so what happens is the T3 and the T4 will also go back and suppress the release of TSH and TRH through negative feedback. Okay, and that's why eventually the T3, T4 level will decline again, and then it will kickstart the whole path again. Okay, now for some people it's hard to visualize this, so let me write it out for you. Okay, in a loop, maybe it will be better. Right. So let's say you have low metabolism again, low decrease in T3, T4. Okay, and that leads to a drop in metabolism, right? Make sense? And what happens after a drop in metabolism? Right, you would increase the release of TRH from the hypothalamus, right? And then when you increase TRH, that's the signal for the anterior pituitary gland to release TSH. What happens after you have TSH? Well, TSH is going to go affect your thyroid gland, right? And tell the thyroid gland to make more T3 and T4. Now, through negative feedback, it's going to go back to your hypothalamus. And then the next thing that's going to happen is it will suppress the release of TRH from the hypothalamus, right? You already have T3, T4 in your system now. Your metabolism is already increasing. You don't need to turn it up more, right? It's like the temperature of your furnace came on, temperature is it's going up. You don't need to keep on running the furnace, right? So you lower down the TRH, and if you lower the TRH, then you're gonna lower TSH, right? And when you lower TSH, what happens is you will lower the stimulation on the thyroid, decreasing T3, T4. Okay. And if you decrease T3, T4, what happens is, the existing T3, T4 that you have, they don't last forever, right? They have half-lives. They're going to break down, and eventually you're going to lower your metabolism, right? I guess I can erase this one now. Lower metabolism. And once you lower the metabolism, right? Once you have low T3, T4, the negative feedback, these red arrows are going to disappear, right? Okay. They're no longer suppressing the hypothalamus, and then you will crank up TRH again, and then TSH, and then T3, T4, and then it just keeps on looping the whole day. So your metabolism stays constant. Okay. And that's what the HPA is for, right? The hypothalamic pituitary axis. All the hormones, all the organs and glands in that path works together to maintain some kind of homeostasis. Are we together with this concept? Any questions? Really? Okay, sounds good. What's next? Oh, okay, yes. So there is another thing I need to teach you. Okay, let's maybe switch to class notes here. All right. So we're gonna talk about two situations here. Okay, we have hyperthyroidism and then we have hypothyroidism. All right. Now I'm just gonna draw the normal path here in the middle one more time, so you know you remember it. Okay, so we start with the hypothalamus. The hypothalamus is gonna pump out. Hopefully you remember by now. TRH, which then acts on the AP, right? And then the AP is gonna release the TSH, right? Which then acts on the thyroid, right? And that pumps out the T3 and T4. Okay. This is basically the HPA. And of course, T3, T4 go suppresses these ones, right? Block the AP and block the hypothalamus in a negative feedback loop. Okay. So let's start with hyperthyroidism. Basically, hyperthyroidism is characterized by high metabolism. Okay, so like these people usually lose a lot of weight. They have higher body temperature, tachycardia, the heart rate goes up, right? And there are different causes of hyperthyroidism. One possible cause of hyperthyroidism is what's called Graves' disease. Okay, so this is just an example. There are other causes, right? I keep on saying. So Graves' disease is an autoimmune disorder. Okay, you have autoreactive antibodies against, against thyroid. Okay, of autoreactive antibodies against the thyroid. So there are these antibodies that you produce that will be permanently stuck on the thyroid. Give me a second. Let me see if I can position this a little bit better. There we go. Okay. Against the thyroid. Okay. So the antibodies permanently stimulates the thyroid. Okay. Just gonna give you a moment to copy that. Okay, so let's see what's gonna happen here with the thyroid gland. Okay, I'm gonna go down here. I'm gonna draw my thyroid again. Okay, and we have all these antibodies that are stuck to it. stuck to it. Okay? And it will keep on stimulating the thyroid gland. So what happens? Well, the thyroid gland is being super stimulated, and so it keeps on pumping out a lot of T3 and T4. Okay, lots of T3 and T4. Okay, which means you have high metabolism. Okay, high metabolism. But wait, there is more. Right? You have high level of T3 and T4. What's going to happen at your AP and your hypothalamus? Are they going to be suppressed, or are they going to be also stimulated? Okay, let's think about that. Sorry, I can't fit everything on the same page. Okay, when you have high metabolism here, high T3, T4, because of the constant stimulation of thyroid, do you expect your hypothalamus and AP to be stimulated, or do you expect it to be suppressed? Why suppressed? Shelly and Zia said suppressed. Why?
Because the T3 and T4 is too high.
Okay, yeah. Zia, you want to explain as well, or?
It's the same thing because you already have the T3 and T4, so you don't need so much of it.
Yeah, basically, right? But then the word I was looking for is like the negative feedback loop, right? So like I didn't draw it in this diagram, but you know the T3 and T4 actually goes back and suppress it, right? You guys remember that, right? So basically this inhibition pathway is very strong when you have a lot of T3 and T4, right? So they go back and they really suppress the hypothalamus and the AP. It's like, hey, hold on, guys. Like, stop pumping out TRH and TSH. We don't need it. We have so much T3 and T4 already, right? Okay. So what happens is, right, this basically have low TRH, right? Okay. And then you have low TSH. Okay. Now, stay with me. Logically speaking, under normal circumstances, when you have low TRH and low TSH, your thyroid will no longer be stimulated, and that should bring your T3, T4 level back down, right? However, despite having low TRH, TSH in this case, your thyroid will continue to pump out a lot of T3 and T4 because they no longer need the stimulation from TSH and TRH. They have their own stimulation from the antibodies, right? Okay, so it doesn't matter. The feedback loop is not doing its job anymore, right? Because there's another trigger, another source for stimulating the thyroid, right? Those autoreactive antibodies are doing the job, right? Okay, so here, for someone who has hyperthyroidism, you look at their blood work, you would expect to have low TRH, low TSH, but high T3 and T4. Do you guys understand what I'm trying to tell you? Like, this is just one cause of hyperthyroidism. Okay, there are other causes which we're not going to go into, but basically, this is it. This is the main idea. Does anyone want to ask anything? Seriously?
Sorry, Professor, you said in their blood work there would be
Low TRH, low TSH, and high T3, T4. Okay. And again, right, the key phrase here to try to understand is the person has high T3, T4 despite having low TRH and TSH, right? That shouldn't happen normally. If you have low TRH and low TSH, logically you should have low T3, T4, right? Look at the map we drew before, right? The little thing here, right? See, low TRH means low TSH, which means you should also have low T3, T4, right? But in this case now, because the stimulation is coming from those antibodies, right? Okay. So what do you think happens to the thyroid gland when it's overstimulated? What happens to its size? Does it get big? Does it get small? Does it, no change? What's going on here?
Enlarged.
And what do we call that condition? Goiter, exactly, right? Okay. So let me show you a picture of that. That's goiter. Okay. And for people who suffers from hyperthyroidism, their eyes also appears that they are like popping out a little bit. That's called exophthalmos. I think that's how you pronounce it. And that's because those autoreactive antibodies also tags the muscle around the eye, causing them to become inflamed. And you know, the eyes kind of, you know, pops out a little bit. So those are the characteristic, like, you know, outer physical appearance of someone having hyperthyroidism. And here are some, you know, symptoms as well, right? Okay, hair loss due to the high metabolism rate. Okay, goiter, we talked about that already. Rapid heart rate, weight loss because you're burning everything that you eat, you know, and perhaps diarrhea as well, because the rapid metabolism causes increased gut movement. Okay, now if we all understand hyper, I'm gonna do hypo now. Okay, but seriously, no question at all? I don't want you to get confused between the two. Okay. So here is the opposite, hypothyroidism. And again, right, there are different causes of hypothyroidism, but they all result in low metabolism. Okay. I'm just gonna put EG here to remind you that that's just an example. So one causes of hypothyroidism is iodine deficiency. Okay. And in this case, basically your body does not have enough iodine. Okay? Not enough iodine to make T3 and T4. Your T3 and T4 needs iodine, right? So if you don't have enough dietary iodine, you can't make T3 and T4. Right? So we usually don't have this problem in you know, North America, because our salt are iodinized, right? They have iodine in the salt. So you know, we get enough iodine that way. But you know, in some places in the world where iodine is not readily available, this certainly could be a problem. So what happens now? Okay, let's see. Okay, we're gonna start at the thyroid again. There is the lovely thyroid. Okay. So it's trying to make T3 and T4, but it can't. It doesn't have the resources to make it. It doesn't have the raw material to make it, right? So it's like really trickling out, right? Just like very little T3, T4. As opposed to over here is like so much of it, right? Okay. So if you have very little T3 and T4, what happens is you have low metabolism. Now, what's going to happen at the AP here and at the hypothalamus? What's going on here? Are they going to be more stimulated than usual, understimulated? What's going on?
Understimulated.
Why is that? Why is it understimulated? I'm not saying you're wrong. I'm just like, you know, trying to.
Because there's not enough T3 and T4.
Okay, so when you don't have enough T3, T4, does your body try to make more to compensate, or does it want to lower it further? Right, that's something to think about, right? Now let's take a look at this. Now normally the T3 and T4 is going to have a negative feedback on the hypothalamus and the AP, right? Okay, but with low T3 and T4 level, right? This suppression here, this suppression is gone. When I use dotted line, I mean it means it's gone, right? Okay, so like this negative feedback is not there. Okay, so I put a star here. Low T3, T4 causes negative feedback loop to disappear, right? So once it disappear, once you take away the suppression because you don't have enough T3, T4, the hypothalamus is going to have a lot of TRH, which stimulates the AP, and the AP is going to pump out TSH, which will stimulate the thyroid. Okay. And tell the thyroid, hey, we have low T3, T4, you got to make more. Right? But here's the problem, right? It's the exact opposite compared to hyperthyroidism. In this case, despite having high TRH and TSH, right, despite all the stimulation you're giving to the thyroid, it's still not able to make T3, T4 because you don't have the raw material, right? So the blood work for someone like this would be high TRH, high TSH, but low T3, T4. Okay. On the other hand, despite low TRH and TSH, there's no hormonal stimulation here, but you still end up having a lot of T3 and T4. Over here, there's a lot of hormonal stimulation on the thyroid. TRH, TSH is like telling the thyroid to make more, but it can't, right? Because it doesn't have the raw material. And so you still have low T3, T4. Okay. Now, what happens to the thyroid? Does it get big, get small? What's going on here? What do you guys think? You guys have 50-50 chance of guessing it right? What do you think happens to the thyroid here?
Smaller?
Why is that? Again, I'm just
I
trying
don't know. It's like, because like, okay, let's say there's a lot of stimulation on the thyroid, but it can't do what it needs to do. Wouldn't it just shrink at that point? Because it's not getting what it needs.
Interesting. Yeah. So like you think, yeah, because it's not doing its job, it's just gonna shrivel away and wither, right? Yeah. Okay, that's a reasonable hypothesis. But actually it's the other way around. It's also gonna get big, right? Because the thyroid is getting all this stimulation from TSH, right? And it's not being able to crank out the T3, T4. So your body thinks, okay, let's get bigger. Maybe if the cells gets bigger, we will be able to meet the demand, right? Okay, so in this case, the person will also get a goiter. Okay, so if you see someone with goiter, right? Let's say you don't really see the eyes, right? Like this goiter alone is not going to tell you whether the person has hyper or hypothyroidism. Okay, so you got to do some blood work. You got to check the T3, T4 level, right? But T3, T4 level is not enough. Okay, T3, T4 levels will tell you whether the person has hyper or hypo, but it doesn't address the cause of the problem. Okay, you also have to check their TRH and TSH. And in these two examples, in the Graves' disease, is going to be like low, low, and high. In iodine deficiency, is going to be like high, high, and low. But there are other combinations as well. Okay, sometimes the problem doesn't happen with iodine deficiency. Maybe there's some problem with the anterior pituitary gland. Think about it. If the person has a problem with making TSH, that will also result in hypothyroidism, right? Okay, because without the TSH, you won't be able to adequately stimulate the thyroid gland, and that will also mean your T3 and T4 level is going to be low. Okay, so lots of possible ways that you can result in either cases. Anyways, something to think about. I mean, don't overthink it. Okay, there are like maybe like 1 or 2 questions on this on the test. And the test bank is randomized, so maybe you won't even get it. But that's not a reason to not study, right? Anyways, I'm going on a babble here. So that's the hypothyroidism versus hyper, right? This is cold intolerance because the metabolism is so low, you feel cold, all the time. and you have slow heart rate, you're going to gain weight, right? Okay, and there's also watery retention in the body, right? That leads to like this puffy face. All right, I think it's time for a break. I will leave it like that. I don't know, is that too small? Is this okay? Like if you guys need to see it, maybe I zoom in a little bit. It's hard to fit everything on the same page. Okay, we'll resume at 9:45. See you in a bit. Okay, let's keep going. Let's go back to here. So in iodine deficiency, which hormone level is expected to be high? Before the break, I was telling you with low T3, T4, right? The negative feedback is gone, and so you would expect TSH and TRH to be high. Okay. This one, high level of calcium will trigger the thyroid gland to release, right? So like student usually forgets after we talk about the T3 and T4, they sometimes forget that the thyroid gland also releases calcitonin, okay, when the blood calcium level is high, right, to bring it back down. So there are 3 hormones that comes from the thyroid gland. So that would be, in this case, the answer is A, okay. When calcium level increases, you need calcitonin. I told you the IN, right? IN reminds you that it is an increase in calcium that triggers its own release. Okay, next we're going to move on to the adrenal gland. Adrenal gland. Just to remind you that the adrenal gland sits on top of the kidney. And then there are 2 parts of the adrenal gland. We have the outside, which is the adrenal cortex, and we have the adrenal medulla. You already know a hormone that comes out from the adrenal cortex. It's aldosterone. Okay, so we will learn that today that aldosterone is actually one example of a group of hormones that comes out from the adrenal cortex. And the adrenal medulla also releases, its own group of hormone. Now, the thing I want you to remember is that the adrenal cortex releases hormones that are related to long-term stress, whereas adrenal medulla releases hormones that are for like short-term stress, acute stress. Okay, I'm going to show you the difference in a second. Okay, so this compare and contrast the 2 the 2 parts of the glands, right? The cortex is the outside, medulla is the inside. The hormones secreted from the cortex are separated into 2 groups. We have what's called mineralocorticoids. Okay, corticoids means they're steroid hormones as opposed to like protein hormones. The way they function is a little bit different, but we're not going to go into the details. The main function of these mineralocorticoids is to conserve minerals, okay? And the key one, the main one, is aldosterone, which of course helps conserve sodium, right? By conserving sodium, that in turn helps you conserve water, and it brings your blood pressure back up, right? So there are other examples of mineralocorticoids, which we are not gonna look into. Okay, so that's the main one. So the aldosterone is triggered through the RAS, but there is an other pathway that could cause it to release as well, and we can look at that in a bit. The other group of hormones that comes out from the adrenal cortex is the glucocorticoids, and the main function of the glucocorticoids is to increase glucose availability. Okay, increase resources availability for your body. And the main glucocorticoids is something called cortisol. Okay, if you use a little bit of those topical cream sometimes for like acne's maybe, or if you have a little bit of eczema that's not going away, your doctor might prescribe you some cortisone, right? Okay, cortisone is essentially the same thing as cortisol. Okay, it helps suppress inflammation. Okay, and we're gonna talk about that in more details in a second. So the regulation is straightly hormonal, okay, through the HPA, the hypothalamic pituitary pathway, right, which secretes the ACTH, and the pathway is very similar to what we saw with the metabolism. Okay, we're going to fill in the last part of the chart later on, and this is primarily important for long-term stress, chronic stress. The adrenal medulla, the inner portion of the adrenal gland, secretes epinephrine and norepinephrine. They are different hormones, but they have overlapping functions. You probably heard of epinephrine. We talk about the EpiPen, right, in second, third lecture maybe, it's the same thing as adrenaline. Okay, so same thing. And this one is controlled through the sympathetic pathway, right? So that's a nervous control. There's no hormone regulation at all, and that's for fight or flight response. It's immediate stress, not chronic, not long-term stress. It's immediate threat, short-term stress. Okay. This is basically what I described to you. You can read it on your own, and we can come back. Actually, you know what? Let's read this as well. So what does cortisol do? Cortisol will help increase blood glucose level by promoting the breakdown of proteins into amino acids. And the amino acid can actually be converted into glucose, right, in the liver. That's called like gluconeogenesis, right? And the cortisol will also promotes the breakdown of fatty acids into the glycerol and fatty acids, and then the fatty acids can be chopped down into double carbons, and these things can be fed into the Krebs cycle and different parts of the metabolic pathway, right? So you switch to these kind of metabolism, and then you kind of save the glucose, the good stuff, right, for the brain, because metabolizing a lot of fatty acids actually lowers your pH, blood pH. So you don't really want that happening too much in the brain, right? You will use this for the rest of the body and reserve the glucose for the brain, because maintaining like a stressful state is energy consuming. Okay, like when you're stressed out because of like things that are happening in life, right? Like if you have to go to school and work part-time job and also take care of your family, that's stressful, right? And that requires a lot of resources to keep your body running, right? And that's what cortisol is there to do, right? Make sure that you have the adequate supply of resources to do that. Okay, so let's take the note again over here. Where are we? Okay, so this is the third pathway, right? This is stress management, long-term stress. Okay. Now, let's not talk about chronic stress yet. Okay, so like the thing I was talking about, right? Like, stuff that happens in life that could stress someone out. Okay? Loss of a family member, employment stress, financial stress. All these things are chronic, long-term stress that spans months, sometimes years. Okay, but your body resource availability can fluctuate up and down throughout the day as well. Okay, so like your cortisol level will also fluctuate to make sure that you have enough to keep you running. Okay, if you're fasting throughout the day, right, that put certain stress on the body, and cortisol will help maintain resource availability, right, for example. So as with other pathways, here we're going to start with a drop in cortisol. Okay, I'm just going to use cortisol as an example, even though there are other kinds of glucocorticoids, but that's the main one, right? So a drop in cortisol means that you have low resources. When I say resources, I mean like, things that keeps your cell running, right? The glucose, the, amino acids and all that stuff. And that will trigger the hypothalamus to secrete CRH. Okay, CRH. It's a releasing hormone, which will then trigger the anterior pituitary gland to secrete ACTH. So the ACTH targets the adrenal cortex, and it will cause it to secrete the mineralocorticoids, such as aldosterone, as well as the glucocorticoids, such as cortisol. And I'm just focusing on the cortisol here. And cortisol, if you increase it, that will result in an increase in resource availability. Okay, by switching to protein metabolism, by switching to lipid metabolism. Okay, now if we're just talking about like a day-to-day situation, like you go to bed, you didn't eat, right? I mean, like you had dinner, okay, at like, I don't know, like 7 o'clock, and then the whole night you're not really eating, right? You're sleeping, right? And then you wake up, 7 a.m. next morning to have breakfast. So there's a good like 12 hours that your body is not gaining resources, right? So your cortisol level is gonna go up a little bit to make sure that you have enough to run through the night, even though you don't really use too much while you're sleeping. Okay, and so once the cortisol level is high enough, it should have these negative feedback just like before, right, to shut down its own production. Okay, but there's a catch here. Let me just put a star here. Okay. The CNS, the central nervous system, can override this negative feedback. During chronic stress. Okay, so if we're talking about persons being stressful for things that are happening in life, right? Not just like daily bodily process, but like the financial stress that I was talking about, right? Other stress, going to school, taking care of family, all these things, all these responsibility can cause someone to feel stress chronically. In those cases, the CNS will override the suppression here, and the cortisol level will continue to go up. Okay. So on a graphical sense, it looks like this. Okay, this is the cortisol level, right? So normally it just fluctuates up and down, up and down. It's going to be able to suppress itself, to regulate itself, much like the metabolism, much like the reproductive hormones. But if you introduce chronic stress, then the negative feedback is no longer there. Then the cortisol level is not going to be able to shut itself down, right? And it's just going to keep on going up, 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 until it reaches some kind of new level. Does that make sense? Okay. Now, chronic stress, as you probably can imagine, is not good for the body. Okay? So high level of cortisol actually has negative effect on the body. Do I have a slide on that? I do. Okay, let's see. So in times of stress, chronic stress, the CNS overrides the negative feedback loop, so cortisol level rises. And what happens is it can interfere with growth, with the immune system, sexual function, cardiovascular function. And it's not difficult to understand why. Because you're taking away all these proteins that have perhaps other functions in the body, and you're burning them as resources. Okay, maybe you're burning some of the complement protein, let's say, right? Okay, so that could interfere with your immune system. Your muscle, right? Muscle is proteins and the actin and the myosin that we talk about, right? And if you're burning those proteins, then it will interfere with the growth, right? That's why kids who grow up in stressful environment like conflict zones, for example, right? War zones, that kind of situation, they might often later on in life have shorter stature, right? Because of the interference with growth and development because of the chronic state, right? And chronically high cortisol level can also harm cells in the hippocampus, and that could interfere with memory formation and learning. And so back to the cortisone, which is the stuff that you put on your acne, for example, or your eczema, that works because cortisol actually suppresses the immune system, right? And one of the immune function is inflammation, right? And so by applying it topically, you can locally suppress the inflammation, which cause the eczema to go away, cause the acne to go away. Okay, that's cortisone, cortisone. Okay? If you have some leftover topical creams in your medicine cabinet, take a look. Okay, so the adrenal medulla is much easier. This one is like, instantaneous release, right? And you know it. I think about last time you got scared, right, by something, or like, you try to cross the street without looking both ways and a car coming at you and honking at you, you immediately jump back and feel the rush of the adrenaline, right? It's an immediate effect because it's nervous control, right? It's much faster, causes the epinephrine and the norepinephrine to be released from the medulla, and it increases your heart rate, respiration, dilation of pupil, and so on and so forth. Whereas this cortisol business, it takes some time because you got to wait for the hypothalamus to release the CRH, and then it causes the anterior pituitary gland to release the ACTH, right? So there's multiple layers of hormones that result in ultimately the release of cortisol. So that takes some time. It's not as immediate. Right? So in general, cortex is for long-term stress, and the medulla is for immediate stress. Okay. Oh, it's right here. I have a slide for it. Okay, and you can read it through yourself. It's basically what I've been telling you for the past, 10-15 minutes. Okay, so epinephrine is secreted by, I'm just gonna tell you the answer, okay, for the interest of time. Hopefully, it's the adrenal medulla. Which of the following is an example of mineralocorticoids? We really only learned one. It's the aldosterone. Aldosterone. Okay, so now we're going to move on to the pancreatic hormones. The pancreas is, of course, located behind your stomach, which is not shown in the picture, but it's kind of closer to the upper left quadrant of your abdominal cavity. And as I told you, it has both exocrine and endocrine function. The exocrine function is the one related to digestion, and the endocrine is related to the cluster of cells called the pancreatic islets, or the islets of Langerhans, and these clusters are responsible for producing hormones. There are actually 3 types, but we're going to only learn 2. These are antagonistic to each other. Okay, so we have some alpha cells that are going to be producing glucagon, right? There's an A in alpha cells, and A here, glucagon. That's how I remember it. And the beta cells, they are going to be producing the insulin. Okay, so again, these are antagonistic. All right, so we learned 3 pairs of antagonistic hormones, right? The aldosterone and the ANH, that helps maintain blood pressure. The calcitonin and the PTH, that helps maintain calcium level. And then we have the glucagon and the insulin, which helps maintain glucose homeostasis. So the brain is constantly going to need glucose, okay, for obviously like a lot of functions that are going on. So like those cells, the brain cells and the red cells in the body, they don't require insulin to absorb glucose into the cell, but other cells that needs a lot of glucose, like the muscle cells and the fat cells, they cannot absorb the glucose from the blood unless there is insulin. Okay. So once you have a meal, right, and the meal has carbohydrates in it, most meals that people eat would have carbohydrates, okay, that would trigger the pancreas to release insulin, and the muscle cells will be able to take up the glucose. The liver cell will be able to take up the glucose, and either you metabolize it, okay, or you can store it for later. Right? We learned in last semester that glucose, excess ones, are stored in the form of glycogen, right? Okay. And if you still have excess glucose afterwards, the insulin can also cause some of the glucose to be stored as fat in the adipose tissue. Okay, so like long-term storage as opposed to short-term storage. Glycogen is for short-term storage. Like if you skip breakfast tomorrow, you're gonna get the glucose from the glycogen. If you haven't eaten for a couple of days, then you're going to tap into your fat reserve to release those glucose. Okay? Or if you have high cortisol level, right, we just learned, then your body will switch to fat metabolism and save the good stuff, the glucose, for the brain. Glucagon is the other way around. Okay, you would release a glucagon, the hormone glucagon, when you don't have enough glucose. Okay, so when glucose are gone, when it's gone from your bloodstream, then you need to release the glucagon to bring it back up. Okay, and it basically reverses everything that insulin does. Okay? It tells the liver to release some of the glucose from the glycogen. Right? Remember, the glycogen is the short-term storage. Right? So insulin cause glucose to become glucagon, to become glycogen. Okay, glucagon cause the opposite. Okay? It takes the glycogen and then change it back into glucose. Now there's a lot of words that start with G here. It's confusing. So let me write it out for you. Okay, so glucose is gonna turn into glycogen, short-term storage, huh? And that is promoted by insulin. That's when you have a full meal. Okay, eat a lot, you have good glucose reserve, you can store some of it. And then when you need it back, when you're skipping meal, then you need glucagon, which would tap into your short-term storage and release the glucose. Okay. Same thing for like fats and stuff. Sorry, for glucose, you can also store them as fat in adipose tissue, and then the glucagon would reverse that process as well if you need them. Okay. So that's how they're antagonistic. Now there's a nice chart that illustrate this over here. Okay. So when you have high blood glucose, like after a meal, you release the insulin from the beta cells, and then it will target the liver, muscle, and adipose tissue to pick up the glucose. On the other hand, if you have low blood glucose, then your pancreas will release the glucagon and then tell your liver and fat tissue to release the glucose. Okay, so you've seen a diagram like this before, but it was blood pressure back then, right? Okay. All right, diabetes. You know what? Let's skip the diabetes for now, because I want to go to fill in another chart for you. We'll come back to this later. And the last couple of hormones is things that we've done already. Okay, so we talk about the gonads and the estrogen, progesterone, and testosterone. We don't have to go through that again. The pineal gland, we also talked about before, right? We know it secretes melatonin, which helps you sleep, plays a role in the circadian rhythm. And the thymus, which we learned like a long time ago, right? In the lecture 3, there's a hormone called thymosin, which helps with the T cell maturations. Okay, so like that's pretty much things that we've gone through already. So what I want to end today's lecture with is this big diagram. Okay, so please turn to that, and we'll fill this in, and then I'll send you on your way. All right. Now, I honestly don't know why. Maybe I'm missing something here, but like they always not have the hypothalamus. I don't know why. Maybe it's like too small or something, but we're gonna put that in. And there is the hypothalamus, huh? Okay. So hypothalamus, we know it's gonna secrete a bunch of RHs, right? Releasing hormones. Hopefully you're reciting it in your mind as I go through it with you, right? So you should remember there are GnRH, TRH, and CRH, right? Gonadotropin releasing hormone, thyroid releasing hormone, cortical releasing hormone. Okay. Gonna get to those in a second. This here, right, we have the anterior pituitary gland. We also have the posterior pituitary. So I know I asked you this like a million times already, but can you tell me, right, what hormone comes out from the posterior pituitary? Anybody?
Oxytocin.
Yeah, oxytocin. What's the other one? Sorry, Leah? You were saying?
ADH.
Yes, that's right. Okay, so we have ADH here and oxytocin. CIN, sorry, tocin. And I'm gonna put a star here. I hope you have colors. Okay, this thing is gonna be like very colorful in the end. These are produced from hypothalamus, right? But then they are stored and released from the PP, right? Okay. I guess not much point coloring it, but you know what the heck, let's do it. That's the anterior pituitary, that's the posterior pituitary. Okay, what about the anterior pituitary gland? How many hormones comes out from the anterior pituitary? All right, so you count your tropic hormone, 1, 2, 3, 4, and then you have the non-tropic, 2 of them, so total of 6. Let's write down the tropic first. What are the tropic hormones? Okay, you can think about it, right? You can write down. I'll write down in like a couple of seconds after you do. Okay. Hopefully you have FSH, LH, right? Can't forget those. And then we also have the TSH and ACTH, right? ACTH. These are tropic hormones. You know, let's bubble them up. Why not? Okay, we did this already, but I'm helping you to memorize them as well, right? By repeating. Yes, these are tropic hormone, which means they target another endocrine gland, right? And we have the non-tropic ones, 2 of them. What are they? Help me, please.
GH.
There's the growth hormone. Very good. Remember the picture with the tallest man and the shortest woman, right? In the world, tallest person, shortest person, GH. And what's the other one? It's related to oxytocin in terms of function. Yes,
Prolactin. Nope.
prolactin. Yeah, you're right. Prolactin. PRL. Okay, very good. Now there's another gland here. I can't believe they include the pineal gland, but not the hypothalamus. It's like it bugs me every time. I don't know why. That's a pineal gland. And there's only one hormone from the pineal gland. Melatonin, right? Melatonin. Your body would produce melatonin when there's a low light stimulation, okay, when it's dark. That's why I don't turn off the light when I teach in the classroom. Some teachers like to turn off all the lights and have the projector. That's just like, you know, hypnotizing, right? Because it's going to stimulate the melatonin release. Okay, so that's the pineal gland. Let's come down here. Is that the thyroid or is that the thymus? Which one is that? What are you guys saying, huh?
Thymus.
Thymus, okay. You know what? Let's do a poll. Although only 5 of you will do the polls, but let's do it anyways. Thymus or thyroid? Right? A for thymus, B for thyroid. Talk about this.
Professor, you're asking about the top one, right?
Yeah, the top one.
Thank you, thank you.
Yeah. All right, we have 50-50 here. Now it's more people saying is the thyroid now. Yeah, that's the thyroid. Okay, thyroid. Okay, that's the one that I keep on rubbing every time I talk about the thyroid. I, kind of touch the thyroid subconsciously. That is the thyroid. It's the higher up one. Okay, the thymus is in front of the heart, and now we know. Okay, so that's the thyroid. How many hormones comes out of the thyroid? Well, there are the T3, T4, and don't forget the calcitonin. Right? Don't forget the calcitonin. Okay, so if you have a highlighter, now is a good time to take it out. Because check this out, we have the TRH, right, which will thyroid releasing hormone, which will stimulate the anterior pituitary gland to release the TSH, which would then stimulate the thyroid to release T3 and T4. Okay, so that's a HPA, one of the 3 that we have to know. Right? You probably have to reduce this later, right, on your own. Print this out, redo it nicely, stick it on your wall. It will help you tremendously on the test. You can see how this is very difficult, right? If you have to do like an in-person test, right? You gotta memorize all the hormones and stuff like that. But like I said, online, usually people are okay. All right. Now you can't really see this, and is just the way that these diagrams are drawn, I guess. It's hard to tell. Okay, so let's color in the thyroid, but we gotta pretend we're gonna look at it from the side. We're gonna take a sneak peek from the side. We're gonna see a little bit of maybe a gland that is piggybacking on the thyroid, right? And that is gonna be the parathyroid. All right, parathyroid gland. Oh boy, what just happened? Everything just shifted. That is so weird. Parathyroid gland. So the parathyroid gland secretes one hormone only, and that is the PTH, parathyroid hormone. Okay. I know it's getting very busy and very crowded here, but I want you to know that calcitonin and PTH, right? These guys, they are antagonistic, right? I'm just gonna circle them in pink, I guess, over here. They are responsible for blood calcium level. Okay, PTH and calcitonin. There are 4 parathyroid glands, right? On the back. We can only see 2 of them over here. Okay, then below the thyroid, this is trachea. You probably recognize that. And this is like just in front of the heart, we have the thymus. Okay, nothing too exciting here. We just have the thymosin for T cell maturation. No point coloring it. I'm just doing it for fun. Okay, over here we have the adrenal gland. We have the outside, which is the adrenal cortex. And of course, we have the inside as well, which is the adrenal medulla. Okay, so let's do cortex first. So adrenal cortex, we have mineralo. It's mineral and then with an O. So mineralo, I guess, corticoids, which is a whole group of hormones, right? And the main one there is aldosterone. And we also have glucocorticoids. And the main one is a cortisol. Okay, sorry, I'm gonna have to change the medulla here. Gonna bend it down here to make more space. Now, before we move on, we're gonna need to have another highlighter here. All right, so we have the CRH, cortical releasing hormone, which stimulates the anterior pituitary to release the ACTH. And then it's gonna stimulate the cortisol, right? That's another HPA that we learned about, right? And then we have the adrenal medulla. This is for immediate fight or flight response, right? Epinephrine, which is same as adrenaline. I'm not going to write it again though. And then the other one is norepinephrine. Spells exactly the same, but with NOR at the front. Okay, so that's that. Now I am just gonna add the heart here, and the heart is slightly to the left here, right? Just gonna put the heart here. Okay, so like heart, and we learned that the heart releases ANH, right? I know it's a lot of colors and you might be running out, but like I said, you can fix this up later. right? So the aldosterone and ANH, that's for blood sodium level, right? Okay, we're almost there. Hang in there. We have the pancreas here. Pancreas releases the insulin and glucagon. Insulin and glucagon. And of course, that is yet another set of antagonistic hormone. This one is for blood glucose level, right? Okay, and for those of you, completionist, we also learned like the kidney releases EPO, right? All the way back in lecture number 1. But we're not going to put it here. Okay, ovaries. Ovary, I guess, single one here. We have the progesterone from the corpus luteum, estrogen from the developing follicle. And the testis here will produce the testosterone, right? And we just gonna need one more highlighter here. I don't know, yellow, I guess. So GnRH is gonna trigger the release of FSH-LH, which then for female, it's gonna stimulate estrogen, progesterone, and testosterone for the male. So this is basically the whole lecture there, right? I mean, like you still have to know what the functions of the hormones are, but in terms of what goes where did they come from, what's related to what, this is it, right? Do you guys have any question? Now, what you need to do between now and Wednesday, excuse me, is you gotta do this thing yourself. Okay, like if you plan to memorize these things, and maybe you should if you have time, because you're gonna need it when you go to nursing anyways, right? If you go into nursing program. So like these would excellent things for these would be excellent things for making cue cards. Okay, for example, basal metabolic hormone. Which one is that? Which hormone is responsible for regulating your basal metabolic rate? Do you guys remember? Anyone at all? No? Oh.
The T3, T4.
Yeah, thank you. T3, T4, right? Okay. Essential for T cell maturation, that's thymosin, right? So you gotta go through this exercise yourself, right? And you probably have to do a couple times, right, before you have it memorized, right? So but this tells you what the hormone and the functions of those hormones are. Okay, I'll of course post the answer key later on. But you got to do that, right? And if you're not like a picture person, if this diagram confuses you and you much prefer to have all the hormones lay out in a chart, right? Then this is going to help you as well, right? So write out all the hormones that are produced from the hypothalamus, right? The GnRH, DRH, the CRH, right? The prolactin and the not the prolactin, sorry, the oxytocin, the ADH, right? So all that stuff are produced in the hypothalamus, right? But I guess this says secreted, so you wouldn't include the ADH and the oxytocin, right? So fill this in, right? And then this is backwards, right? Now it's all scrambled up. If I ask you, where does glucagon come from, right? Do you know which gland we're talking about, right? So you should know, oh, glucagon, pancreas, right? So do this between now and Wednesday. And then when we come back together, we'll fill in the hormone chart, and we will talk about the diabetes. And we're just gonna spend maybe first half an hour or so wrapping up lecture 3 on not lecture 3, lecture 12. I mean, I don't know what I'm talking about anymore. Wrapping up lecture 12 on Wednesday, and then we will take up the lab on Wednesday as well. And then that would be it, right? Yeah, so next week, Monday, we will have the review for the final exam, final test. And then you will do your final test next Wednesday. And then that would be all it. Okay. I sent out an email earlier asking you to do the class climate, the student course survey. Okay, if you've done that, great. If you have not, please take a moment to do that. Right now, I see that 11 of you have responded. Probably it's the same 11 of you that are all here in the live lecture. Okay, but if you're watching this recording and you haven't done the feedback yet, please take the time to do it. It's very important that we get the information from you. Okay, that's it for today. Thank you for coming. I'll see you all on Wednesday. Have a good one. Bye.